Okay, so starting tomorrow, we are back to like regular scheduled lessons. We are starting our last unit, unit 7, tomorrow, and it'll probably take us through May 9th is when I have you scheduled to take the unit 7 test. I have a retake plan for May 14th, but then after that, it's just finals review and you take your final. So even though our next unit test isn't until May, so you have like 150 assessment points going in May, that can really change your grade. Make sure that you are coming to tutoring, trying to do corrections on your more recent unit 6 test, maybe retaking it for a better score. But we only have 3 unit tests this semester, so you need each of them to be good. And this last unit is called quadratic functions. Unit 6 was introduction to quadratic functions. So unit 7 is like kind of a repeat of unit 6, just like with more things going on. So today's Kahoot is going to review some quadratic function stuff. On a side note, we are still deciding as math teachers whether or not your unit 7 test you will use graphing or just like a regular scientific calculator. So like Desmos would be a graphing calculator. The scientific one would not let you graph. Because this unit is mostly about how to solve it algebraically, not by graphing. So it's still something we're talking about and considering, so just kind of keep that at the forefront of your mind. But here's the first one for the review. Take notes as you go. That's your points for the day. It's going in the assessment category for math lab. Okay, the shape of the quadratic function matches which description best? The quadratic function is a line, curve, parabola, shape. I got it right. Oh, so remember, take notes as you go. The description curve is not like specific enough. Exponential functions have curves to them. All right, parabolas are the formal name of our U-shaped graphs. Quadratic functions, their U-shaped graphs are called parabolas, in case you didn't know that. That was the password for one of the tests.
I added that to the list.
Miss Medina.
Okay, so then on to the next one. On a side note, V-shaped graphs are absolute value functions, but we don't really do much with those this year. Okay, the y-coordinate of a point where a graph crosses the y-axis is called what? The y-coordinate of a point where a graph crosses the y-axis. Y-intercept. Kind of like when you intercept a football, like an interception, it touches the y-axis. It intercepts the y-axis. At your y-intercept, x is always 0. All right, next one. Remember, take notes as we go. I'm checking as we go too. A set of all the x values. A set of all the x values. Okay, domain. Domain is all the x's in the function. Do you guys know what the domain is usually of our quadratics? But like, if our quadratics either look like this or this, my domain is always what? What's my domain for quadratic functions always? If they look like either a normal U or an upside down U, my domain is always gonna be what? And domain is all the x values. No, that's all I'm looking for. So remember, domain is telling me all the possible x values in the function. So imagine this is on a coordinate plane. Will this graph eventually touch all the x values? Okay, where does it stop at then? No, because the arrow means it goes on infinitely. Okay, so you think that there's no x values to the left of this or to the right of this on the graph? Maybe this is where the y ends, but not the x's. So what is my domain for quadratic function? Does it look like it goes infinitely to the left? Does it look like it goes infinitely to the right? All right, I'm not gonna tell you the answer. Just think about that, it's probably gonna come up. It does, but the x-axis doesn't go up, so we don't care about that for domain. Okay, so anyway, the lowest point on the parabola is called what? The minimum. The lowest point on any graph is your minimum. For our quadratics, it's technically just the y value of your vertex. So moving on. Okay, the x coordinate of a point where a graph crosses the x-axis. Okay, x-intercept.
Nice one, eh?
Where it intercepts the x-axis. What is the most amount of x-intercepts I can have for a quadratic? Remember, they look like this or like this. What's the most amount of x-intercepts I could possibly have? 2. And then could I have 1 x-intercept? You could, if the vertex is on the x-axis, like that is an example, then that's where it just has 1 x-intercept. Could it have no x-intercepts? Yeah, it could be drawn something like this, where it doesn't touch the x-axis at all. Those are the 3 options. 2, 1, or no solution. Okay, so then next one. The section of a function that is going up from left to right. The section of a function that goes up from left to right. increasing intervals. So they will have increasing intervals if that section goes up from left to right, like how you do. Okay, next. Remember, take notes as we go. That's your question today. Just 1, 2 answers, jot some stuff down. A set of all the y values. All the y values. The range. So it's what we were talking about earlier, listen, is that the parabolas go either infinitely up or infinitely down. So you do always have a boundary when it comes to the range. It's just wherever it stops on the y-axis. So say this is what I'm working with. All right, say this is at 5. I'm just making it up, 5 on the y-axis. We'd say that all the y's on this line are greater or less than 5 for my range. Less than, yeah. All of these below are smaller than 5. Does it touch the 5? So then also equal to. So you will have one boundary unless they say otherwise, like unless it's a real world situation and it ends at the ground or something like that. But you will have at least one boundary for the range, and it just depends wherever it ends. So like this one, let's say it ends at -5. Because this one goes infinitely up, we say y is greater than or equal to -5. All these y values are bigger or touching the -5. Good question. Okay, so here's the next one. The highest or lowest point on a parabola. The highest or lowest point on a parabola. No, vertex. So it says highest or lowest. In other words, the turning point of the parabola is your vertex. That's good. Next one. Okay, what is another term for x-intercept? I don't think we've talked about this yet, maybe some of them. I feel like, it's probably gonna, no, probably no line. Keep writing. So zeros you should know for sure because we just took a test, well, not just took a test, but like a few weeks ago, our last unit test asked you to solve for the zeros, so you're pretty familiar with that. Zeros are x-intercepts, but also we call them roots. So if they say solve for the quadratic roots, tell me what the x-intercepts are. And we also call them solution. That's going to be a big thing in this next unit. The solutions are your x-intercepts. So if it says solve this quadratic, the solution is your x-intercept. Questions on there? Although, but again, remember, you might not be allowed to use graphing on this next. Depends what we decide. So that's why we're going to show you like other ways to get those solutions in this coming up unit. But just be aware, they're also known as your x-intercepts. Okay, the given equation represents what type of function? If it looks like that, what type of function is it?
I think I did.
Only 4 people got that right.
Listen, okay, can't remember.
All right, by the time you leave 9th grade, you need to be able to tell the difference between linear, exponential, and quadratic functions. Those are the big 3 we cover this year. And if it has it where the variable x, like the input, is the exponent, then that's an exponential function. That's like, and they use different variables, but that's like y equals a times b to the x power. Okay, whenever x is the exponent, that's exponential. Okay, the given equation represents what type of function?
I chose
What about?
Dude, I think running, bro. Nah.
Okay, linear. That was an easy one. That one I already in middle school. But they highlighted the M and the B. What do we call the M? Slope. What else do we call the slope? No. Slope slash rate of change, okay? Now the B is your y-intercept, and we also call the y-intercept what? Like in a real world problem, it's our starting amount. So if you compare this to how they represented it, like in that last slide, they also used M and D, but they did it like this: y equals b times m to the x power. I don't like doing this because I feel like it can be a little confusing, but like you remember in exponentials how this was your starting amount, the number without the exponent was your starting amount, and also your y-intercept. And then this was what it was changing by each time, like multiplying by 2, multiplying by 1/2, whatever it was. So pretty cool, like representation. But anyway, moving on. The given equation represents what type of function? What type of function?
Right.
Quadratic. What is the giveaway that it's quadratic?
Squared.
The x squared. The quadratics can be as simple as just this, or you could have other stuff going on. But the highest exponent has to be like squared, like it can't be anything higher, or else we call it something different. Good there? Okay, so that is our quadratic function. That's a big thing this unit. Okay, the given equation represents what type of function? Can you read all the options? Oh,
Sorry.
Okay, parent function, it's still a quadratic, so at least I marked both of them as right. But this we call the parent function, because it's the most basic one that you can have. like the minimum requirement for it to be a quadratic. All right, this will be the last one. The section of a function that is going down from right to left.
Are we keeping these?
Yeah. I already, I'm going this way. I looked at your papers already. You guys. Okay, I feel like this is wrong, actually. I think it should have been green. Because if it's going down from right to left, it's actually increasing. Don't you agree with me?
I don't think so.
I think there's some error in the question making. I'm pretty sure it's supposed to be increasing, whoever. But anyway, the podium can pick a prize from this basket.